Good day, everyone. Welcome at the UFA Academy lecture on chronic fatigue syndrome. My name is Anna Kuczborska, and I'm UFA Academy coordinator. And just before I pass the floor to our guest, let me tell you a bit about UFA Academy. UFA Academy is a series of open lectures in which all of us can participate, either on-site or online. Some of them happen also in a hybrid formula. The whole program is available online at ufa.eu/academy, but also on UFA Virtual Campus. For instance, you can participate virtually in offerings from University of Eastern Finland or University of Antwerp. And just one last thing, since this is a hybrid event, please wait with questions till the end. And those of you who are here and wanted to ask a question, wait till you're given a microphone. Only then our virtual participants who are still joining will be able to hear you. And now I will pass the floor to our guest, Sławomir Kujawski, PhD from Nicolaus Copernicus University from Collegium Medicum, will tell us a bit about chronic fatigue syndrome, which I believe that we all believe we have. Now prove us wrong. Thank you.
Chronic fatigue syndrome. I'm interested in machine learning and artificial intelligence, and I also provided some research on aging, and we conducted the very first longitudinal study on aging in Poland. But as you can imagine, I will be focusing on chronic fatigue syndrome today. So what is that? A syndrome means that there is a cluster of symptoms subjectively perceived by patients. Chronic fatigue means that it is chronic, as every chronic disorder, there is a chronic component. Typically, we believe that those symptoms has to perseverate for at least 6 months to be diagnosed with chronic fatigue syndrome. And I believe that the crucial and very important symptom is called PEM. This is called post-exertional malaise. So I will be describing this more. It is something that is occurring in most of patients with chronic fatigue syndrome, and it significantly disturbs their daily life. Recently, there are a lot of research on the commonalities between long COVID and chronic fatigue syndrome. For instance, both of those could be triggered by a viral pathogen, or in terms of chronic fatigue syndrome, maybe even bacterial or other pathogens. And there is an overlap between some symptoms in those two conditions. Still, it is unresolved if long COVID is the same as chronic fatigue syndrome, or maybe some fraction of patients with long COVID would develop chronic fatigue syndrome. Nevertheless, it shows how valid research on chronic fatigue syndrome is. So, as I said, syndrome means that there is a constellation of symptoms. And I believe that most of those symptoms that you can see, you would say that they're highly unspecific to any kind of particular disorder. But there are some issues, there are some disturbances that could be measured in an objective manner, and I would focus on that. The first one is so-called brain fog, so it's about cognitive function decline. Especially, there are problems with verbal fluency. Patients who undergoing post-exertional malaise tend to report that they have problems with talking. As me, like now, I'm providing a lecture to you. If I will be a CFS patient with PEM, with severe PEM, it will be not possible for me to be fluent in a kind of language. And both cognitive function and neural structure could be measured in an objective manner. And here is one of many examples done by Sonia Marshall and her group in Australia. This is one of the centers that is interested in ME/CFS. They showed that there is a very deep portion in the brain called brainstem, And there are significant changes in the volume of the subproportion of brainstem in ME/CFS in comparison to healthy controls. It is a rather recent study. Another thing that could be measured in an objective manner is so-called autonomic nervous system dysfunction. So recently, we tend to believe that there are two components of autonomic nervous system, sympathetic and parasympathetic divisions. Sympathetic one is, as you can remind yourself from biology in high school, sympathetic division is responsible for fight or flight response. And parasympathetic is responsible for resting and digestion. And it is perceived subjectively by patients, but also it could be measured in an objective manner. And here is a very important study. It is a meta-analysis, so it's analysis of other studies from 2019. And it showed that there are objective parameters that are significantly changed in patients with chronic fatigue syndrome. One of those is an elevation in resting heart rate, elevation of heart rate response on tilt, and the ratio of low frequency to high frequency of heart rate variability. This is one of those indicators, indirect indicators of autonomic nervous system function. Those parameters are increased in chronic fatigue syndrome patients. In comparison, maximal heart rate and heart rate at anaerobic threshold both are measured during response on physical exercise. Those parameters are lower in ME/CFS in comparison to healthy controls. And there is a whole hypothesis behind what is the pathological process leading to this, but we would skip. You can ask questions later on it. And I would like to focus more on post-exertional malaise, because I believe that this is a cardinal symptom of ME/CFS. And to be honest, I also believe that if you would treat post-exertional malaise in an effective manner, then in fact we would alleviate substantially the burden in multiple patients with chronic fatigue syndrome. So post-exertional malaise refers to worsening of symptoms after some kind of exertion. It could be physical, so it could be after a bout of physical exercise, but it could be also after emotional experience or cognitive exercise. So it's not that restricted to physical exercise per se. What is really interesting is that those symptoms, increase in symptoms, occurs 24 hours or even 72 hours after the initial stressor. So it's delayed in time. And this is something that for sure differentiates patients with ME/CFS from healthy controls and even other disorders. So how it looks like. There is a simple model for it. So there is a stressor, some kind of a stressor. A combination of those three stressors could be going on typical Polish wedding, when you have to stay for a whole night, dancing if you're a woman with ankles that you don't like. So there is also emotional experience that could be not that pleasant, and you have to keep on talking with your significant ones and other people. So those are all those three stressors in the same time. And you have to know that many ME/CFS patients decline invitation for weddings, and it's not because they don't want to go on the wedding, but they know what would happen afterwards, 24 hours after this wedding. So there is some kind of a stressor, and it leads to post-exertional malaise, so a significant increase of symptoms, and it turns into a crash. And this crash is described by ME/CFS patients as a disease inside of a type of another disorder. So you can see those photos. Those photos are taken during the same day. So you can see now why multiple ME/CFS patients don't like to be called as you look normal or you look healthy, because indeed they can look healthy. Look on the photo on the left side, but and they can engage in some kind of social activities, normal social activities, as taking part in a wedding. But the crucial component of this disorder is this payback, so-called payback, that has to be paid 24 hours or later after this exertion. So those two photos are for the same person in the same day. So what could be done in terms of objectifying post-exertional malaise? We can apply something that is called a 2-day cardiopulmonary exercise testing. So we can do this cardiopulmonary exercise testing when patient is walking on a treadmill or riding on a stationary bike or doing any kind of other exercise. And the idea behind it is that we can measure a lot of physical function in response to this physical exercise. So we can measure heart rate using ECG, we can measure gas respiration using the special mask, we can measure blood pressure of the patient, we can measure the saturation of oxygen in the blood, and we can measure multiple other parameters. So this is something that can provide assessments of multiple physiological systems at once. And to be honest, to be fair, cardiologists were, I suppose, the first clinicians that they discovered that, well, you can measure parameters, some kind of cardiac parameters during rest, and it's good, it's all right. Nowadays, it's still a gold standard for some indicators, like ejection fraction during rest. But also, you can measure the same system, so let's say cardiopulmonary system, in response to any kind of a stressor. And this idea behind it was adapted by other clinicians. So, for instance, maybe you heard about diabetes, that they can occur during pregnancy, and you can measure glucose during fasting. Of course, you can measure in the morning hours, but you can also measure the dynamics of glucose level in response to any kind of a stress. So we can be asked to drink water mixed with a lot of glucose in it, and then there is a response on this kind of stress. The stressor here is the glucose. So what we do here is they apply very same paradigm behind it. So the first CPET serves as a stressor. So physical exercise, especially intensive physical exercise, could be a really potent stressor even for healthy people. And this is the first stressor. What we really want to measure is that how the same patients would respond to the same stressor 24 hours after the first stressor. So that is why it's called repeated CPET test or 2-day CPET test. And those are parameters that could be measured in response to physical exercise using CPET. There are multiple of those. And one more thing is that, well, indirectly by measuring intake of oxygen and exhalation of carbon dioxide, you can have a window to the metabolism on the cellular level. It's very indirect, but it's really good. So we breathe out, typically we breathe out CO2 and some kind of water in gas form. The water comes from our body because typically, mainly we are just water. We consist 50% and more of water. And oxygen, where oxygen comes from? Of course, from the atmosphere. We believe that we intake oxygen from atmosphere and we give out to the atmosphere CO2. So the question is, where the carbon comes from the CO2? And you have to know that this carbon comes from the metabolic processes. So everything that we eat on the daily basis, protein, fat, carbohydrates, as you can see, carbohydrates include carbon in its component, then it has to be metabolized to give us energy. This energy comes from the bonds between carbons, and we have to expel out this additional carbon to the atmosphere. That is the CO2 comes from. So on very indirect level, but CPET allows us to measure the metabolism of the patient. And it's something that you cannot, fool as a patient. You can, if you believe that those patients with ME/CFS are just acting that they're sick, you have to know that, well, maybe one can act that, oh, my cognitive function is really declined. Give me 5 words, and no, I don't repeat them because, oh, I just forgot them. Maybe you can fool neuropsychiatrists, but you have to believe that you cannot fool the amount of oxygen that you can intake or even the CO2 that you exhale. It's something that is related to biology, very hard. And so there's a paper on inability of ME/CFS patients to reproduce the same maximal oxygen intake after 24 hours. So there is a meta-analysis from 2020 that shows the pathology in ME/CFS in response to the CPET. What is really interesting is that during the first day, there are no big differences between ME/CFS patients and controls in terms of results of such CPET test. But those differences are coming to the surface 24 hours after the first CPET. So healthy controls tend to stay the same on the level of their parameters or even improve a little bit. But what could be noticed in most of these ME/CFS patients, they tend to crash after those 24 hours. So these parameters get worse. And here is the chart showing it, that there is even an increase in the decline of CPET parameters in response to mild, moderate, or severe ME/CFS patients. So from now on, I will start shameless self-promotion. So I was talking about research of other people. Now I will be talking about research of our group. The first one that I would like to share with you is that I told you that there are autonomic disturbances in patients with ME/CFS. But as you can imagine, ME/CFS is rather a highly heterogeneous group in terms of symptoms presence and intensity of those symptoms. So what we have done is that we dig down into what really is ongoing with this autonomic nervous system. And I talked about two branches already, about the sympathetic and parasympathetic branch. And as you can see, some patients with ME/CFS have sympathetic overexertion with dysautonomia. Some, namely 21 from our cohort of 102 patients, had parasympathetic dominance, and 41 had balanced autonomic nervous system function. So as you can see, there is rather high heterogeneity in this group. To do so, to reveal the subgroups, we applied unsupervised machine learning methods. So maybe we can apply even better title. We can add machine learning or AI to the subtitle, and it will be much more sexy. But it is what it is. So another one is a network analysis of symptoms co-occurrence in chronic fatigue syndrome. And here is the distinction between symptoms occurrence on female versus males. As you can see, there are no big differences between those two sexes. And here is co-occurrence of particular symptoms. So as you can imagine, post-exertional malaise is highly related to much of other symptoms, including fatigue severity measured by CFQ scale and fatigue impact scale. Another thing is, of course, brain fog, so impairment of memory or concentration is also related to a lot of other symptoms. And the other crucial factor here, I suppose, in multiple patients will be unrefreshing sleep. And what we have done later is that we tried to help those patients in terms of non-pharmacological therapy. You have to know that there is no valid biomarker for ME/CFS, so the diagnosis is a really rough process both for clinicians and for patients. And in addition, there is no treatment, there is no cure for ME/CFS patients. So we had no idea what type of pharmaceutic we can apply, so that is why we tend to do some non-pharmacological interventions. In this case, we applied aerobic physical activity program. But what we have noticed is that around 50% of patients dropped out from the study. So they decline, some of them decline even to start this therapy, some of them decline to continue this therapy because they said that this physical activity makes them worse. So what we have done is we applied a classification model to distinguish those patients who completed the therapy versus those who did not complete. And we asked the model, could you predict, based on baseline measurements, even before taking part in this therapy, which patients would complete the therapy versus which would not? And we believe that there are three parameters based on which we can distinguish completer versus non-completers. In very brief aspect, very brief conclusion, those who are more severe at the baseline had decreased chance of completion of the program. And then we switched our gears a little bit. So we thought, well, maybe we can learn from other disorders or other conditions. And you have to know that there is something that is called whole body cryotherapy. It is rather popular in Poland. It's kind of a physical therapy where you undergo exposure, very brief exposure on very cold temperature. And it was shown that it's effective in athletes, But also, it's shown to be effective, this is from our review from 2023, in multiple conditions, in multiple disorders, including those disorders that are related to chronic inflammation. You have to know that it is believed that whole body cryotherapy tends to be so effective in the reduction of inflammation that athletes tend to postpone exposure on cold, like football players from USA, from NFL, 8 hours or even more after resistance training exercise. So we believe that to promote muscle hypertrophy, so growing of our muscles, a little bit of inflammation is needed in this mechanism. But if you would apply cold exposure just after this physical exercise bout, then you would decrease inflammation so much that would decrease the hypertrophy gain. So you have to also know that in terms of chronic fatigue syndrome, there is also one of those components that is called chronic inflammation. Some of inflammation marker on increase. That is why we decided to apply whole body cryotherapy to our patients. And what I discovered pretty soon is that our colleagues from USA, from UK, they were not familiar with whole body cryotherapy whatsoever when we started the project in 2016. Right now, things has changed. So thanks to celebrities as Joe Rogan, they promote cold body exposures, cold water immersion on social media, and that is why more and more centers providing whole body cryotherapy are growing up around UK, around London. But as you can imagine, this is not how a patient undergoing a whole body cryotherapy looks like. It comes from a movie, Terminator movie, and that was the main protagonist of Terminator, and pretty soon he was killed. But and Terminator said, "Hasta la vista, baby." But it was not that exciting. You have to be a patient that was not so exciting. Patients just went in the chamber first to the antechamber, and then to the main chamber. In the main chamber, there is a very low temperature, something like minus 130 degrees of Celsius. But what is paradoxical is that thermal comfort, so-called thermal comfort, so how well do you feel, is rather better than during cold water immersion. So maybe some of you tried, well, maybe cold shower or something like this. It's much more convenient to undergo whole body cryotherapy than cold shower. So it was not that extreme. Of course, other factors play a role in here, low humidity in the chamber, as well as brief exposure. So we started from very short duration, 30 seconds per exposure in the first week of the therapy, up to 150 seconds in the second week of the therapy. You have to also know that even professional athletes, marathon runners, expose themselves in whole body cryotherapy after up to 3 to 4 minutes, not longer. They see no point in staying there longer. And we applied multiple examinations before and after this intervention. So first we started from medical examination. It's 2024, but still to diagnose as ME/CFS, to be diagnosed, this is an exclusion diagnosis. So first you have to exclude all of other disorders that can potentially explain symptoms of ME/CFS. And it should be also noted that I believe most of chronic conditions can induce chronic fatigue. So if you have untreated hypertension, indirectly it can affect your sleep. And then it can affect that you have a chronic fatigue, but it's also, you have to be also aware that chronic fatigue does not equal chronic fatigue syndrome. Those are two very different things. So we applied subjective scales to measure symptoms of those patients. We measure cognitive function both before and after, autonomic nervous system using objective and subjective method. Aortic stiffness, we also provide blood and stool examination. And from this very busy slide, I can tell you that in general, patients with chronic fatigue syndrome improved in a significant manner in response to this whole body cryotherapy. The same with their parameters of autonomic nervous system. So blue dots are chronic fatigue syndrome patients. Here is before and after the therapy. Those orange dots indicates results from control, healthy controls before and after therapy. We think that whole body cryotherapy, for sure, it's not a cure for ME/CFS. So unfortunately, we still have to look for the cure for this terrible disorder. But on the other hand, there are not many supportive therapies that are effective in ME/CFS, and I believe that this study needs to be replicated. So we know from the psychological studies that replication is a really crucial part of the process. But if other group would replicate our results, then I believe that we can think of if the cold therapy could be included in the guidelines of therapy on chronic fatigue syndrome. So as you can see, we and other researchers on ME/CFS are quite confused because we don't know what to treat, because we don't know exactly what is the problem, what is the biological mechanism underlying the pathology of ME/CFS. And that is why we still struggle, we still look for the diagnosis process that could be based on some objective indicators. And here in this paper, together with our colleagues, we described a method that would be based on the cells from blood. So blood is a tissue that is really easy to examine, really easy to get from the patient. So I believe that you didn't hear about examination of neural tissue from the living patient. It's rather not possible, but most of you have underwent in your life examination of your blood tissue. So that is why it's so crucial to do it. And by application of fancy methods called Raman spectroscopy, we believe that there are some differences in the types of amino acids between healthy controls, mild, moderate, and severe patients with chronic fatigue syndrome versus multiple sclerosis patients. And then in collaboration, we applied an ensemble method. So ensemble learner is kind of a model in machine learning. When you cluster together more than one method of classification. So here we clustered together 8 different classifications models, and then we created whole pipeline that the data went through. Then based on this ensemble learning method, we developed one classifier, and that was highly accurate in distinguishing patients with chronic fatigue syndrome versus multiple sclerosis and healthy controls.
Do you have any questions or comments that you wanted to ask? And there are no comments in the chat. I was personally thinking about, but it's just me, about the distinction between the chronic fatigue syndrome but also depression. Mm-hmm. And could you tell us a bit more about that?
Yeah, so as you can see, multiple symptoms of chronic fatigue syndrome might overlap with major depressive disorder. You have to know that there is one very characteristic feature of ME/CFS that is rather not occurring in major depressive disorder, and is post-exertional malaise. So here is the main distinction. Post-exertional malaise is something that is rather highly specific to ME/CFS patients. On the other hand, if you are talking about major depressive disorder, the recent meta-analysis showed that physical exercise is one of those non-pharmacological interventions that could be applied to reduce the symptoms of depression. Of course, it's not working in every patient with depression. It works just with mild cases, because if you cannot get up from the bed during early morning, then probably you are more severe. But still, typically, patients with major depressive disorder does not suffer from PEM. And physical exercise, especially in mild cases, it improves their state rather than worsening it as in ME/CFS. And to be honest, there is an organization, international organization called American College of Sports Medicine. And this organization, together with World Health Organization and CDC, states that we should all undertake regular physical exercise. So we all should do 150 minutes of mild aerobic activities per week, and we have to engage in two times per week in resistance training, something that strengthens our muscles. And it's for general public, and the same or very similar approach is used in multiple chronic conditions. But as you can see, it seems that there is one exception. I mean, those patients with PEM. Probably you have to do individual program, physical activity program for those patients, if at all.
Then if there are no other questions, then I suggest to those of you who are watching us online to just step from the computer, do some exercises, see how that works for you. And thank you. Thank you for coming. Thank you for giving this lecture to us. And I hope that we will see each other at other UFA Academy events. Thank you.